David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic, sketching graphs of quadratic functions. And before we start, I want to talk about what we mean by sketching. Plotting points is a different process. Plotting points is where you pick your x values, you make a t-chart, and you put in x values, maybe like this, and then you run them through the function and you get your y values out. Then you take those points and you plot them on the graph. This is a time-consuming process, and it's not always easy to capture the vertex with your first selection of x values. So sometimes you end up having to graph a whole bunch more points. It just takes a while. Sketching uses your knowledge of the various forms of quadratic equations to find intercepts, shapes, and vertexes. Okay? So let's do that. Okay, so here's our quadratic function. It's in standard form. Now you might want to convert it to vertex form to find the vertex, and you could do that, but we don't need to. Okay, so let's take a peek at that. The first thing, the Y-intercept. This one is always pretty easy on standard form, not on vertex form, but on standard form. Remember, the graph crosses the y-axis when x is 0. So what we do is we set x equal to 0 in these two spots, and we figure out what f of x or y would be. So I can just do this by inspection. If x is 0, these two terms go away. The y-intercept is minus 3. So the way we write that is 0, negative 3. Now let's do the x-intercepts. Now the x-intercepts happen when y equals 0. So to find them, what we do is we set f of x or y equal to 0 and we solve. This one is easily factorable. It's a product sum type. What two numbers multiply to negative 3 that add to negative 2? That's negative 3 times positive 1. 0 equals x plus 1 times x minus 3. Set each of these equal to 0 and solve. So x is negative 1 and x is 3, which gives us the y-intercepts of negative 1, 0. I'm sorry, x-intercepts of negative 1, 0 and 3, 0. So now we can just graph this based on these three intercepts, and we can end up with a pretty good sketch. Y-intercept is 0, negative 3. In fact, I'm taking a look at all my numbers. I don't get higher than 3, positive or negative. So for my class, this is perfectly acceptable. That graph has everything that I need to graph these 3 points and sketch my parabola. So 0, negative 3, that's that point right down there. My next one is negative 1, 0, so that's going to be approximately there. And the other one is 3, 0. So now I have 3 points. Okay? Now, the trick here is to sketch a parabola that goes through those 3 points. You might be wondering now, well, does this thing open up or down? If you look, it'd be pretty hard to draw a parabola connecting these 3 points that opened down. It's just, you can't do it. So the parabola has to open up. That's confirmed. Remember, our a here is positive 1, so it's positive, so it has to open up. So what I can do, the other thing to notice is that my x-intercepts are spaced out at 1 and at 3. So the vertex is going to be to this side of the y-axis. Remember, the vertex is exactly between the two x-intercepts. So in fact, I could kind of get a feeling for where the vertex is. It's going to be somewhere on this line. I'm just going to sketch it like that. Now for sketching from intercepts, that is a good enough graph. Okay, let's try another one. This time we're in vertex form. Let's talk about what we know here. My a equals 2. It's positive, so it opens up And the 2 means it's narrower than y equals x squared. So already we know something about this parabola. Now, check this out. This parabola is in vertex form. So remember, it's x minus h plus k. Since there's nothing out there, k is 0. So my vertex is going to be, change the sign of that, it's going to be 3, 0. So now we know, opens up, narrower than x, y equals x squared. We have a vertex at 3, 0. Let's find us some intercepts. So, the y-intercept. That's when x equals 0. So let's plug that in. 2 times 0 minus 3 squared. That's going to give us, this is just negative 3. Squared is positive 9 times 2 is 18. So what that means is that the y-intercept is 0, 18. Okay? And then finally my x-intercepts. Now we set y equals to 0 and we solve. So this is going to be 0 equals 2 times x minus 3 squared. This one's pretty straightforward. I'm just going to get x alone. First thing I'm going to do, divide both sides by 2. This is convenient. 0 divided by 2 is still 0. So that got rid of my 2. Now I have x minus 3 squared. Now I'm going to take the square root of both sides. Again, square root of 0, still 0. 0 equals x minus 3. Move my 3 over. X equals 3. So suddenly, with this one, I only have one solution. So my vertex, my x-intercept is 3, 0. Now remember, when you have only one x-intercept, it means the graph touches the x-axis only at one point. And that's going to be the vertex. So let's take a look. Oh, guess what? The vertex is 3, 0, and the x-intercept is 3, 0. So that makes sense. Let's sketch our graph. Scaling your axes, we talked about this in an earlier video. Before you start getting really busy making a million tick marks on your axis, look at the points you have to graph. I've got to graph 3, 0, and I've got to graph 0, 18. That's a pretty big number. So what I'm going to do is I'm going to go 10, 20, negative 10, positive 10, negative 10. Something like that. Okay, that's good enough. My vertex is at 3, 0, so that's going to be somewhere right about there. And then my y-intercept is at 0, 18. So that's going to be somewhere right about there. Okay? And that's pretty much all I've got. I only need these 2 points. I can sketch my graph now. This is f of x equals 2 times x minus 3 squared. Okay? So again, we're sketching our graph. So we're just finding some key points. In this case, we found the vertex and the y-intercept, and then the x-intercept was kind of duplicating the vertex because it just touches the x-axis there. So we just had 2 points, but that's enough to make a really reasonable graph. Okay, let's try another example. This function in standard form. You could convert this to vertex form and work from there, and that would be an acceptable way to answer this question. But I want to show it to you in standard form because that's going to bring out different processes that we've done already. Okay, so my function is negative x squared plus 2x plus 3. You might remember this from an earlier video. We used the same function to illustrate how to find intercepts. And we're going to do that again here. But first, I want to find the vertex. Okay, so the vertex, remember, the x-coordinate is minus b over 2a, and then whatever that value is, you plug it into the function to get f of minus b over 2a. Okay, so let's do that. Here's my minus b over 2a. My b is 2. My a is negative 1, 2a, and I have that minus sign out there. So this is going to end up being positive 1, because I have 2 over negative 2, but another negative, 2 negatives makes a positive. So there's my first term. So let's just start filling that out. The vertex is 1, comma, something else. Now we're going to put in my 1 into my x here, and that's going to spit out my y value. So 1 squared is 1. My negative makes that -1. 2 times 1 is 2. So -1 plus 2 is +1, add a 3, and we have 4. So my vertex here is the point 1, 4. Now let's take a look at finding some X-intercepts. Now remember, actually let's do the Y-intercept first because that's super easy, right? The Y-intercepts happen when x is 0. So x squared, 0, 2x, 0. All that's left is 3. So the Y-intercept, remember, is 0, 3. The x value is 0, and the y value given by our equation is 3. Okay, so now let's find the X-intercepts. A little bit more complicated. We need to set this function equal to 0. Remember, when it crosses the x-axis, the y value is 0. So I'm just going to write 0 equals -x squared plus 2x plus 3. Now, having a negative in front of the squared term just makes factoring difficult. Now we're in a really easy place to fix that. If we just multiply both sides of the equation by -1, we're going to end up with, again, 0, because -1 times 0 is still 0. And we're going to change the sign of all of these. X squared minus 2x minus 3. Now this should look familiar. We just did this same function. This is 0 equals x minus 3 times x plus 1. Right? So this is going to give me my X-intercepts of +3, 0 and -1, 0. Like that. Okay, so now I have a Y-intercept, 2 X-intercepts, and a vertex. That's 4 points. That's going to make sketching this parabola super easy. Let's take a look at that. So I need to scale my axes on my graph. Let's take a look at the range of points I need to deal with. 1, 4, 0, 3, 3, 0, and -1, 0. So 4 is my biggest number, so I'm going to scale this in a super easy way. I'm just going to throw a 5 out there. That ensures that I'm going to get all my points on my graph. Okay, my vertex is 1, 4. That's approximately right there. That's my 1, 4. My Y-intercept is 0, 3, so that's right about there. 1, 4, 0, 3. My X-intercepts are 3, 0, approximately there, and -1, 0, approximately there. So now you've got to look at your points. This is a tough spot. I see students mess up on this. How does that parabola open up? Is it up or is it down? Well, if you look at those 4 points, it'd be pretty hard to draw a parabola through all of them that opened upward. You just can't do it. You're going to have to create some kind of wiggle parabola or something kind of crazy. But it's pretty easy to make it open downward. We just draw our line right through like that. We know that's the vertex, so that's the turning point. So I can draw my graph like that. Okay. So that's another parabola sketched instead of plotting points. We just figured out our vertex, our Y-intercept, and our X-intercepts, and we created our graph based on that. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.